Hi guys, this is the second half of the lesson that looks at some of the practice questions that were assigned. So if you haven't tried this, please do so. The first one is not too bad. I'm just going to go through the solution here. It's already written out. So we've got this problem where it says we've got a revenue given by this quadratic equation, and x represents the price in dollars of each component. And then we've got another equation, the linear one, that's given the cost. It says determine the price that will allow the production to break even. So break even means that the amount that you're bringing in a company, the revenue, is equal to the cost, so the money going out. So we're setting it up so we have revenue is equal to cost. So this equation equal to this equation. So if you do that, it's really the same as the other practice ones we did during the lesson. Set it up here, move everything to one side, and then if you can, we try to solve it by factoring, and this one it does after you take a common 10 out. We've got this left over, so two numbers that multiply to give 2 times negative 21 and add to give 11. And if you think about that for a little bit, work it out on your calculator maybe, you've got 14 and negative 3. And you factor it all down, and then the last step is to solve, and you get two answers. One is negative 7, and the other is 3 over 2, or 1.5. And negative 7 doesn't make sense for the price of something, so it's got to be $1.50. So therefore, the price needed to break even is $1.50. Okay, the next one's a bit more complex. It says a baseball is hit at a high velocity modeled by this equation. So there's our quadratic, where t is the time that has passed since the player hit the ball, and h is the height after t seconds. So there's this bird was 21 meters high when the ball was hit, and is flying in a straight line with a vertical climb of 2 meters per second. Will the ball hit the bird? So we've got this equation that we need to put together, where if you imagine it, you've got this bird starting up here at 21 meters, and it's climbing ever so slightly in a straight line. Let me make that a bit better. Sometimes it's hard to write on this. So it's climbing ever so slightly up to over 1 over time. So if you think of that as an equation, my slope is the 2 that's going up, and so it's 2, and it's for every second. And then the y-intercept, where it's starting at, is 21 meters high. So there's our equation that we need in order to try to figure this out. And that's the height over here. What we want to do is figure out, does the ball hit the bird? And so we're going to do the same as we did before. So I'll call this equation 1 and this 2. And so if I make them equal to each other, 2t plus 21 is equal to this negative 5t squared plus 32t plus 1, and move everything to one side. So I've got minus 5t squared, and move the 2t over, that gives me plus 30t, and move the negative, or 21 over, that gives me minus 20. And so I can factor a common factor just to make the numbers a bit smaller. Minus 6t plus 4. So it says, does the ball hit the bird? And if so, find the times that this unfortunate incident occurs. If not, celebrate and explain why it didn't. If I just want to check to see if they intersect, that means that the discriminant is going to either be equal to 0 or the discriminant is going to be greater than 0. This would have two solutions. This would have one. So in order to check this, I just simply have to take the discriminant and sub in the values that we've got and see what I get. So I've got 1 for A, B is negative 6, and then C is 4. So subbing that in, so I got negative 6 squared minus 4 times A, which is 1, times C, which is 4. Remember, this outer value of negative 5 doesn't impact these numbers. So this becomes 36 minus 16. Well, that's obviously 20, and that's greater than 0. So yes, therefore the ball is going to hit the bird. In fact, what this is telling us is that there's two solutions and the ball hits the bird twice. Realistically, that's probably not going to happen, but in the shape that the bird is going, it's going to get hit, it's probably going to drop down, and it's not going to hit it twice like this. So anyways, we want to, if so, we want to find the times that this occurs. So we need to use the quadratic formula, because if you look at this equation, two numbers that multiply to give 4 and add to give negative 6 doesn't exist. So my times, and I'm just going to quickly plug all this in. And if you want, you can try this yourself. So negative 6 squared minus 4 times A was 1, C was 4. So we already know that that comes out to be 20 inside here because we just calculated that. And then 2 times 1 at the bottom. So I've got 6 plus or minus root 20 over 2. Again, we talked about this. We don't need these in roots because it's time. So I've got two answers that are going to come up. One is the plus of the root 20 and the other is the negative. The plus one comes out to, and you can punch this into your calculator, I got 5.24 seconds. And then the other one is 0.76 approximately. So in this case, the bird probably gets hit at this 0.76 here, and I'm going to imagine the bird's dropping down like that and doesn't get hit again, but maybe it keeps going, who knows. So therefore, the bird gets hit when t equals 0.76 seconds, like that. Great. Okay, next one, it says determine the value of k in this equation. So here's k that will result in the line blah, y equals 2x plus 3 having no points of intersection. So like before, we've got two equations. No points of intersection. We want to figure out a number that'll go in here so that they never intersect. And so if we want no points of intersection, we want the discriminant less than 0. So if I let these equal each other, let me just move that negative up a bit. And that's equal to the 2x plus 3. If I move everything to one side, so I've got negative 2x coming over, so that becomes negative 6x. And then I've got plus k but minus 3. And that's equal to 0. So these are the values I want to put into my discriminant. So I've got a, b, and my c is going to be 2 terms. So I've got my discriminant less than 0. And this is going to allow us to solve for k to find out what values k would be in order to be less than 0. So if I sub this all in, still less than 0, so I've got 36 minus 12 times negative 3 plus k. Keep working that out. So negative 12 times negative 3 gives me plus 36, and then minus 12k. So you may or may not remember, but whenever you're solving with inequalities, whenever we're trying to solve an inequality, we have to keep the variable positive. So rather than move these guys over, I'm going to move this over to the other side. So I'm going to add 12k, which normally we would keep the variable on the left, but I want the variable positive. So I'm going to put it over here. And then obviously this is just 2 times 36, or 72. So that's going to work out, so I can still divide by 12, so that I've got k is greater than 6. So I would normally write this as k is greater than, opening up towards the k is greater than 6. So what this means is that any number greater than 6, so I can plug in any number here, 6, 7, or 7, 8, 9, doesn't matter how big, but as long as it's greater than 6, I will have no points of intersection between this and this thing. And so that has some benefits in applications in business or things like that bird example. You can estimate stuff. So no intersection, so therefore k is greater than 6. There will be no points of intersection. And that's it. Okay, if you have any questions, of course, I'm always available, extra help every day, and we'll talk about this in class, next class. See ya.